It helps us ship products faster for our clients. They are happy, and it helps us build software that our development team can easily understand and use for faster development and saves their time. So it's a win-win for both. This library is responsible for doing all the Bluetooth interactions. We call it Element Sync, and we are trying to build it in a generic way so that we can use it for every other client or in-house products. You don't have to build the same structure again and again. You can just reuse and ease the entire process of development. Doing that every time for all the clients will waste a lot of time. So the idea is to have all that generic protocols implemented in Element Sync, which we can directly import into client packages. HydroTune is an app that we built for one of the clients. It's basically used to control hydraulic diggers, which currently needs to be done manually. All you have to do is use this app to adjust the steps that you want to move, and then it'll adjust the pressure sensor readings on those hydraulic diggers. You can do all of that remotely. You don't have to do all that configuration manually, which is a little risky. You can use this app to basically run this actuator motor. So if you just feed in the values, you can see the device actually moving. All this is done through Bluetooth interactions using Element Sync. We are doing all the step adjustments and getting the pressure sensor reading back. We are able to do multiple asynchronous requests in a very stable manner. There are typically two types of Bluetooth devices, the classical Bluetooth device and the BLE ones, which uses less energy to interact. Most of the devices that we work on are based on BLE protocols so that the device keeps on running in the background for longer periods. Working with BLEs is definitely challenging. You have to do a lot of boilerplate code before you actually get to the real stuff. You have to take care of permissions, you have to take care of scanning the devices, subscribing to services, then enabling notifications, then doing the read and write requests. You cannot send a very big chunk of data at once. You have to split your request into multiple chunks. And it goes same way when you receive data from Bluetooth device. You have to process all those chunks and create a final byte stream that you can read and show on the client app. So implementing a queuing mechanism for something like this was a little challenging. While designing Element Sync, we were thinking of how we should structure the entire code so that it creates a generic layer that creates a separation of concerns and also make sure that we are not making the code very tightly coupled. What we end up doing was create a middleware layer which will take care of all the client specific requirements and also keeping client package clean, since the middleware takes care of all the intermediate transformations. There are a lot of prerequisites that you need to do. One of them is making sure that you have all the Bluetooth permissions and taking care of requesting permissions, handling the behavior in case the permissions are denied, and how you're going to scan the devices, connect to those devices. All those things are taken care of by Element Sync. We don't want to add all those functionalities just at one layer where there's just one file having a lot of code. So what we did is we segregated into multiple sections. So we have got Element Sync as a higher layer wrapper, which has Bluetooth controllers, which has Wi-Fi controllers, and which has server API interaction controllers. Now Bluetooth controller is responsible for doing all the Bluetooth related stuff, and it navigates the flow to BLE scanners. That's how the control flows from one file to another. We keep the code segregated and modular so that it's easy to understand and add more functionality to it. Now BLE scanner navigates the flow to different type of handlers, whether we are talking about how we are discovering the services while connecting with them, or whether we are reading something from the Bluetooth, or we are writing something to the Bluetooth device. All those things are managed using different sort of managers, and that's how you layer the entire code base. A modular patterns is what we have tried to implement here. So right now the library is pretty much working for all the Bluetooth interactions. It is capable of handling multiple asynchronous Bluetooth requests. We have a lot of ideas on how we want to make this library even more advanced. It was not just about the Bluetooth interactions, it was also about creating a library that can do all sort of data flow for any device that we've got. So it can be a server that you want to connect to, it can be a Wi-Fi dependent device. We are probably going to start with API server implementation first and then see how we go forward with that. Let's try to optimize and create something that we can reuse.